All right, DNS exam number 2, problem number 24. You were given a function y equals e to the 2 minus x, and they tell you that the tangent line to that particular curve at the spot 1e intersects both the x-axis and the y-axis, and that a triangle is formed, and we're supposed to come up with the area of that triangle. So the first thing I did is drew out a really rough sketch of what that curve looked like. And I'm wondering at this point how important it is to be able to get that, because I'm guessing a number of you looked at this and said, I'm not quite sure what that graph looks like. It didn't have to be super accurate, but what I'm hoping you were able to tell is that it was an exponential function, and because the exponent had a negative x in it, it's actually going to be a decay function. I just thought about this really quickly, thinking, okay, if x was 0, my y value is e squared, so I just kind of randomly put this point right up here, and then I just reasoned that the bigger x gets, the smaller your exponent gets, becoming 0 and then eventually negative, but e to a small power, even a negative, is going to approach 0 but never quite get there as x increases without bounds. So that's how I was able to figure out fairly quickly what the graph looked like, and it's not super accurate, but I don't think it really matters. Now, to figure out the area of the triangle formed, well, first I formed the triangle by drawing that tangent line, which doesn't look like I drew it terribly well. It's a little steep, but that's okay. And then just using a convention that we should use all the time, B always gets used for our y-intercept, and then A is what gets used for the x-intercept. As we've talked about, that's actually the reason why in y equals mx plus b, B is the letter used for the y-intercept, because A is being used for the x. So we needed to figure out the equation of that red tangent line, and then from there we could figure out both its y-intercept and its x-intercept, and we'd be able to get the area of that. Okay, so for equation of a tangent line, the first thing I did right here is I took the derivative of this exponential function. Same base to the same power times the derivative of the exponent, which was -1, and there's our derivative. We then wanted to evaluate that derivative at the point of tangency, which was 1e. So we went ahead and said we were going to take the derivative of y with respect to x, evaluated when x was 1. The exponent became a 2 minus 1, which was 1, and the slope of that tangent then was just a -e. So, using the slope of our tangent right here and the point of tangency right here of 1e, I went to point slope form and did y minus my y coordinate, so that was y minus e, was equal to the slope of our tangent, which was -e, times the quantity of x minus the x coordinate, so that was an x minus 1. Thought it would be easier from there to find the x and the y-intercept if we put this in slope-intercept form. So I went ahead and distributed that slope of a -e and got y minus e is equal to a -ex plus an e. And careful, this is an e times x, not e to the x. And then lastly decided to add e to both sides there and got this equation in slope-intercept form of y equals -e times x plus 2e. That's the equation of our red tangent. And because it's in slope-intercept form, y equals m times x plus b, this number right here is your y-intercept. If you thought about this, that y-intercept of the graph itself right there, when x was 0, was the value of e squared, and this value right here at b turns out to be 2e, a little bit less than that. So we know the y-intercept, and we know that this side of the triangle has a length of 2e. Now we needed to figure out the value of a. And to do that, a trick you might have learned back in Algebra 1, we know that y is going to equal 0, and then when that happens, that's going to give you your x-intercept. So I went back to this equation right here and put in a 0 for y, and I went ahead and put an a in there for x, although I think a lot of people would probably just leave that as an x and solve that way. So made that substitution. This negative term I was going to bring to the left side to make it an EA is equal to 2E. And since we're trying to solve for A, I divided both sides by E and simply got A is equal to 2. So now we knew that this whole piece down here had a length of 2. So that becomes the base of our right triangle. That becomes the height of our right triangle. So now nice and easy from here, guys, that the area of a triangle is 1/2 times its base times its height. So 1/2 times a base of 2 times a height, I'm sorry, you can't see that, times a height. There we go. A was 2. 1/2 base times height. And we've got a 1/2 times a base of 2 times a height of 2e. The 1/2 and the 2 cancel. The area of that triangle then is 2e square units. And the answer is A. And I was also asked about number 26, which I thought I did well, and then it turned out I did number 25. So if anybody's wondering about 25, there's the solution to that. I'll post number 26 in just a minute.